Hello. In this short video, I'm going to show you how you can set up load testing in Fabric using a Fabric notebook from the Fabric load test tools. So I have a Fabric environment here. So first of all, what I need to do is log into the Fabric toolbox. So I'm going to, zoom in, aka.ms Fabric toolbox. If we go here, this will take you to the instructions for the tools called Fabric Load Test Tool. And here are the instructions that I'm going to mostly be following. So first of all, back in Fabric, what I need to do is create a workspace. So I'm going to create a new workspace and I'm going to call this Fabric Load Testing Demo and apply that. And this is a brand new blank workspace. So I need a semantic model in here. So I'm going to go and get one from the MSLearn sample set of semantic models and reports. You probably have your own one, but for just a demonstration purposes, what I'm going to do is download the customer profitability sample PBIX. It's not a particularly large one. I have that on my local machine now. So let's bring that report and semantic model into the workspace. And what we're going to do is set up load testing to fire queries at the semantic model that belongs to this report. But the first step is we need to capture the queries that we want to send, because the queries need to be relevant to the report. So we're going to need to use Power BI Desktop here. So what I'm going to do is open the report that's connected to the semantic model in the workspace, and I'm going to download this file. Now you could choose either. I'm going to select to download a copy of the report with a live connection to the semantic model in the workspace, because I don't necessarily know how big the semantic model might be. I don't want it to be too large. So I'm just downloading the report, which I'm going to open in Power BI Desktop. So now that that's downloaded, I'm going to open, browse this device, and I'm going to find that report, which is opening in Power BI Desktop. Now I'm not editing the report, all I'm doing is using Power BI Desktop to capture queries. So once this is open, and you'll notice in the status bar when it does open that it will be connected in live connection mode. Okay, so now we have it open. What we can do is collapse the various panels and open the one that I'm interested in, which is the Performance Analyzer tab. You will need to enable this in the settings. And we're going to select Start Recording, and this is going to allow us to capture those queries. And here's the critical part. What I now need to do is start interacting with the report. So I'm going to go through the tabs and just let the visuals load. And each one of these entries in the Performance Analyzer is capturing a query, and we can interact with the report, try and make this as realistic as your users may also interact. And I'm going to click through to different pages. Every time I perform an action here, it's generating new queries down here, and I'm going to go to the executive scorecard and make some changes. The more work you do here, the longer the test will be, but the more effective the load test will be for you. And I'm done here now, so I can stop the recording, and I'm going to export all of these captured DAX queries to a file locally on my machine that I'm going to upload into the workspace. So we're done now. We can close Power BI Desktop and we can get rid of that. So if we go back to the workspace now, what I now want to do is add a lakehouse, because this is where we're going to store the queries, and this is where we're going to store the logs when we're running the load test as well. So I'm going to create a lakehouse called Lakehouse, very creative, imaginative name, and we're going to upload those queries that we just captured. Okay, so in the file section, I want to create a subfolder called Perf Scenarios Queries. And this needs to match the code. If you make a change here, you will need to update the code in the notebook to match, but this should work fine for me. And what we now need to do is upload a file, and I'm going to search on my machine, and I'm going to find the file called Power BI Performance data.json, which is what I just captured now in Power BI Desktop. So we're going to upload that file. You can see one I had previously uploaded. And if we have a look in the queries section of the Lakehouse, we can see that file. And if we even click into it, we can see the JSON logic, format content. In here, there will be, in amongst a bunch of things, DAX queries. The load test will look for these query expressions when it's running the load test. So that's done now. Now we need to import the notebooks that are going to run the load test. And there's a couple of ways you could do this. You could go to the over here and just simply download these and re-import them. Or we have text in the instructions that just does that automatically for you. So I'm going to create a new item, and this is going to be a notebook. Now the purpose of this notebook is just simply to make the copy operation of these notebooks much easier. So if I paste that code in when it lets me, cool. Now with Python, it's indent sensitive, so I just need to take out that tab. We can run this as a pure Python notebook. It doesn't necessarily need to run as a PySpark notebook. So I've got that as a Python, and I don't need to connect to a Lakehouse either. And I'm just going to simply run this cell, and we're going to throw this notebook away. What we should see when this cell completes is some output to say that I have successfully imported a notebook called run load test and also run perf scenario. But for this feature to work, we need to install the fantastic tool Semantic Link Labs that hopefully you're already well and truly familiar with. And that's now complete. So if we jump back to our workspace, we can see that we have downloaded run load test and run load test scenario. I'm going to delete this one just to clean that up. Now we're going to need to run the load test against the semantic model. So I'm going to copy the name of the file and have that in my buffer, and I'm going to open run load test. We don't need to touch the other notebook. This other notebook here is just run from here, so the only modification we need to make is in this run load test, and it needs to be connected to the Lakehouse we just created. When you download it, it's going to try and connect to the Lakehouse that it was used in GitHub. So let's get rid of this Lakehouse. So we can here remove all sources to start from scratch. Now we need to add an existing data source, which is the Lakehouse we just created, and we can check to see whether this is the right Lakehouse, because if we expand files, we will see there is a folder called queries, but there's no folder called logs. What will happen is when the load test runs is it's automatically going to create a folder here and put the output of logs here. Let's give this a name. Test load test 1. We'll put our semantic model name in here, and you'll notice there's a few parameters here between lines 13 and 19 that you can customize. I only want to run 3 concurrent threads, and we will perform maybe just one iteration of this load test, and that's it. We should be good to go. We can run this code cell here. Now this is going to fire up a Python virtual machine inside Notebook, which is going to call our other notebook in parallel 3 times. And if I scroll down to the bottom of this notebook, we will be able to see the output here. So I wanted to run 3 threads. You could do 5, you could do 10, you could do 20. If you start increasing the threads, what you might need to do is spin up a more powerful virtual machine. I'm using the default, which only uses 2 vCores and 16 gig of RAM. But what you can do at the start is run maybe this cell here and say you want to use 16 cores or 32 cores when you want to do a much heavier load test with say 400 threads, say, for example. And they would appear down here underneath this first output. And you can click on these snapshot links to go and look into each individual instance of one of those parallel runs and see all sorts of interesting information, including any errors or any notes that might appear. When this is successful, what we should see is, if I refresh my folder section here, I have a log folder, and in my log folder it has created a folder named the load test with the date and time, and in here it will start CSV data will start appearing once we get 100% complete on some of these here. Now, if this completes successfully, these will all show 100%, they'll go green. And we've got not only the output of these queries in terms of how many rows were run, the duration for every single query, etc. It stores it in a data frame so that we can do some work locally to do some analytics, but we should also have it over here in some files. If we refresh here, there we go, we do have some CSV. Now, it's up to you what you do with this now. You could append this to a lakehouse table, you could throw it away. Ideally, what you should be doing is running multiple load tests so that you can compare load test to load test to get some benchmarks and compare. So if I collapse that, what we can also do here now is just run this code cell in the bottom, which is going to give us a standard text chart, matrix showing every single query, the duration, start time, how many rows, the actual query itself, the visual it came from. There's a lot of stuff here that you can perform analytics over. And also you can go and start creating charts here to show average query times. You can build your own metrics. I recommend P50, P75, P90, and that's it. And then all you now need to do is just come back here to rerun, hit the play button, and it's up to you whether you increase the threads, change the delay, maybe use some different queries. It's designed so that it's very easy to tweak and customize. So hopefully that shows you how easy it is to set up a load test using Fabric. It's good to go now. Please put any comments underneath the video. I'd love to hear your suggestions, and also you're very welcome to come and contribute. It's a GitHub repo, so I'd love to have help in making this better. All right, thank you.